Hey guys, welcome to my channel. So today's our lead code biweekly contest 139. Second problem is find a safe walk through a grid. So basically you are given m cross n binary matrix grid and an integer health, and you start from the upper left corner 0 0, and you would like to get to the lower right corner, that is m minus n and n minus 1. Okay, so you can move up, down, left or right from one cell to another adjacent cells as long as your health remains positive. So cell of ij with grid ij is equal to 1 are considered unsafe and reduce your health by 1. Okay. And at the end, what you have to do, you have to return if you can reach the final cell with a health value of 1 or more, and false otherwise. That is, if your health is 0 or less than 0, then you have to return false, otherwise you have to return 1. So if we see this particular example, here we are given a grid containing binary values and health is 1. Okay. So you have to basically check whether if is it possible to move from this point to this point. Okay, and your health is basically greater than 0. And when you move through any of these cells, if you encounter the cell containing one value, then your health value is reduced by 1. Okay, so in this example, as you can see, our health is 1. So if I move in this way, okay, then I reach this particular m minus 1 and n minus 1 cell. Okay, and my health is 1 only because I haven't encountered anyone, so my health is not reduced. Okay, that's why. So suppose if for the same problem, if I choose this path, okay, this path. So if I move from 0 to 1 at this particular point, my health will be reduced by 1. That means it will become 0. So if my health is 0, then I have to basically I can take the path, so I have to return 0. Okay, so I have to basically find the path that gives that from which we reach this particular point, and it's our health is also greater than 0. Okay. Hope you have understood the problem. Now what can we do to solve this particular problem? So the first thing that comes into our mind while looking at this particular problem is basically brute force, that is checking all the possible paths, okay, from 0 to m minus 1 and n minus 1 index. Okay, and at each basically track we will we will track the health also by as soon as it becomes less than 0, then we do not follow that particular path and we find the new path. Okay, in this way, and we will basically find all the paths, and if I don't get any of the path, I will return false. And as soon as I got one path, okay, then I will simply return 1. Okay. So for that, what I will be doing is here, as you can see, this is our function that is given. We are given this grid and health. Okay. So I have taken this total row and total column variables containing the number of rows and number of columns. Okay. Here I have taken set. For now, forget about this set. Okay. I will let you know why I have taken the set. Here we are calling this recursion. Okay, and here I am sending this grid health 0 0, which currently represent my row and column values, index values. Okay, total rows, that is the total number of rows, total columns means the total number of columns, and s basically set. So just ignore it, assume that it is not, it isn't there for now. Okay, so here in our recursion function, it is of pool type. Okay, we are receiving this grid health row column initially 0 0 values, total rows and total columns. And okay, so what would be our base case? So see, we basically traverse from 0 0, and we traverse till m minus 1 and n minus 1, and here it is given that we can move in all the four directions, that is upwards, left, right or bottom. Okay, it is given. So we will do the same thing. What I will do is, firstly, I will check the base cases. Okay. Before that, let me guide you through this particular code. This I am calling a recursion. Okay. So on each recursion, here I am this column plus 1 means suppose I am here. Okay, at this particular point, that is 1 1 index. Column plus 1 means row is 0, but the column value is has increased by 2. Okay, from 1 to 2. So that is 1 on and 2. So this particular index. Here row plus 1 means this row is value is incremented, but column is the same. That is 1 only. So 2 comma 1. And for this column minus means this particular value. That is row is same, that is 1, but the column value is 0. So 1 comma 0 index. And for this particular thing is this. Okay. So as you can see, we are moving in all the four directions. Okay. So if you want to move with the four directions, we also have to check the edge cases. Okay. Because see, if I am here, if I move upwards, then I will get an error, right? Runtime error, that is index out of line. Okay, bound. So what would be our test edge cases? If row is less than 0, this particular row, it is initially 0. If it becomes less than 0, or it becomes greater than or equal to total rows, that are total number of rows. Okay, here it's 3. So we will start from 0. So 0 to 1 is valid, but as soon as it becomes 3, then we will return 0. Similarly for column also, if it's less than 0 or it's greater than or equal to total column, then I will return 0. Okay, forget about this set. Okay, so if grade of, and then this condition, that is if grade of row of column is equal to 1, that means as soon as we encounter 1 when we are like following any path, then what we have to do, we have to reduce our health by 1. And if I have to check whether we reach our goal, or if we reach our goal, that is this particular value m-1 and n-1 value. Okay, that is our row becomes total row minus 1 and columns become total column minus 1. Then what we have to do, if our health is greater than 0, if we reach this point and if our health is greater than 0, then I will return 1, otherwise I will return 0. Okay, and similarly, I have to check one more condition, that if our health is less than or equal to 0. See, like when I reduce this health, if my health has become less than or equal to 0, then I have to return 0. Okay. Then we will perform this particular, if none of these conditions satisfies, so we will not return 0 and we will move forward with these conditions. Okay. So this is the code for finding all the possible paths. Okay. So initially we are here. If I uh, run this particular code on here, so currently we are at here. Okay, row and column are 0, so 0 0. So what will happen, it will check whether it is less than 0, this condition. So this condition do satisfies. Okay, so we will it won't return 0. I will check whether our this particular index value is containing 1 or not. So no, it isn't. So health won't be reduced by 1. Initially health is 1. Okay, I will check whether this is our goal, that is m-1 and m-1 index. No, it isn't. It is 0 0 index. Okay, and our health is less than or equal to 0 or not. So health is 1, so this will also not. So that means we will do this recursion. So in this recursion, I will move column plus 1. So basically here I will reach here. Then again I will check this condition won't satisfy. This condition satisfies because grade of row and column is 1. Okay, so health is reduced by 1. So health becomes from 1 to 0. So as soon as it becomes 0, what do we have to do? Like here, if health becomes 0, we will return 0. So I will return. Okay, so we will not follow this particular path. So all the paths going from this particular index has basically we won't go through them. Okay, so now what will happen is we will return here. Okay, if 0, because we have received 0 here. If 0, that means nothing. I have to do nothing. If it is 1, then I have to return 1. Okay, but this one we will return only when we are at this particular index and our health is greater than 0. Okay, so initially I have received 0, so I will not return anything, so I will move here. So row plus 1, so I will move here. Okay, row plus 1 again, row plus 1, this index, this particular recursion will be called. Initially our row is 1 and column is 0, because row is 1 and column is 0. Then I will move to row is equal to 1 and column is equal to 1. Okay, by this particular recursion, and again I will check that I have encountered 1 here. Okay, our health is reduced, so health has again become 0. So basically I will return it. So I will come here. So again basically I will not I won't find answer if if I move through this particular path, so I won't. So again I have returned 0. So basically here we have received 0. So again this particular recursion will be called. Okay, the second one. So what does this mean? That is row plus one and column. Row plus one means this here. Row plus one and column. So this do not satisfy any of these conditions because its value is also zero. Like it is the correct. It is the index is not going out of bound. Okay, anything. So health is also less than zero because health is initially one. Okay, so we will move to this particular recursion. So this recursion will column plus one. So I will move here. Again, this particular uh, uh, index values do not satisfy any of these conditions. So we will move further with this particular recursion. So I will move here. Okay. After this, see, after this, again, this particular thing will be called, and then we will see that I have encountered one. Okay. As soon as I have encountered one, I will reduce my health by one. Health becomes zero. Okay. Here. So as soon as I encounter health is equal to zero, I will return zero. So basically zero is returned here. So I have reached this. Now I have to basically find some another path from this particular index. Okay. So I have seen here this path is not valid. So I will come here. That is row plus one. But row plus one means row size will become three. So three is equal to this total row. I will call the recursion, but this condition will satisfy and it will return zero. So again, I have encountered zero here. So basically, I have gone through this second also, but I have encountered zero. Then I will move through this particular recursion. That means column minus zero. So I will move here. But as you can see, we have already come from this particular path, right? Because see, we are traveling in this way. So I cannot basically move towards the same index because by doing this, we will move to an infinite loop. Okay, that's why. So I have to keep the track of those path or those row and columns index values that I have reached, that I have visited. Okay, that's why I have taken this set variable. Okay, here. Okay, so at each basically at each point, what I was checking is if set is containing this row or column value or not. If it is, that means we have already visited this particular index value. And if I have visited, that means I have to return zero. And why I have to return zero? Because we have already moved through this path and we haven't found the answer. Because if we have found the answer, as soon as I found the answer, I return one. Okay, and see if one, then I will simply return one. So basically every recursion will return one, and at the end I will receive one. Okay, here at this particular point. That's why. So we know that if I have visited this particular index value, and then I do not have basically found the answer. Okay, so basically I won't move to the same index again. Okay, because also it will take me to the infinite loop. So if I was here, if I moved from here, that means our set is containing this particular row column value. Okay, so I will check here if s dot find row column. Yes. So what I will return? I will return zero. So again, it will return zero. So basically, from here, here, and here, we have received zero. Okay, from right, left, and bottom. So we will move to the top. So we will check whether top is valid or not. So here, this is moving towards the top. Okay, we will check that we have visited top or not. No, we haven't. So basically the condition, and it also do not satisfy any of these conditions. So what I will do, I will come to this recursion column plus one. If I move here, that means I will encounter one. So again I will return zero. Now I will move here, but again I have visited this, so again I will encounter zero. I will move here, but again here is one, so I will also, it is visited also, so I will receive zero. So again, this particular fourth equation will run and I will move towards the upwards. Okay. Now I will check this is valid or not. No, it isn't. It also do not satisfy any of this condition. So this particular recursive call will happen and column plus one. So we will reach here. So we haven't reached here and this particular index value is also valid. Okay. So again, this recursion will call. Okay, again we will come here, so we will move here. After this, again this recursion will call. Okay, this particular, so column plus one. That means I will reach here. So at this particular value, that is total column is equal to column. Okay, so it will return zero. So I will move downwards. Again I will move this. Again this recursion will be called. Again it will receive zero. So again we will move here. So as soon as I basically reach this particular root, that is here I am checking. Okay, that is total row minus one and total call minus one. And I will check health is greater than zero or not. Yes, health is greater than zero because we were moving through all these zero indexes. Okay, so I will return one. So this will basically return one, and this return one will happen until we reach to this particular point. Until this also return basically returns its value one, and at the end from here it will return one, and we will go down. We will get the answer. Okay. So hope you have understood this problem. If I run it. See, it is working fine for these test cases. Okay. So coming to the time complexity of this particular problem. So what it could be, see here, at we are finding all the parts, and at each particular grid value, we are taking four directions. Okay, one, two, three, four. That is left, right, top, and bottom. Okay, so four values, and there are number of values are suppose n, so 4 to the power n. Okay, where is n cross m, so 4 to the power n cross m. Okay, so basically this is the problem complexity, and also we are using the set. So for searching the set could be log n, so 4 to the power n cross m into log of n. Okay, so this particular code will give TLE. Okay, so how we basically have to optimize it. So what we will be doing for optimizing this particular code is basically we will be keeping the track of all the paths that we have traversed. Okay, so like in this condition we were using set. So basically for this particular, if I am moving from here, so it was like tracking the path of this particular value. But again, if I move from some another path, then again basically all the previous value that was stored in the set will be lost, and again we have to start. Okay, so basically it was the complexity of 4 to the power n. So in order to optimize it, what I will be doing is I will be using this DP vector. Okay, so I will be using this vector. The code is similar. Okay, the code is exactly the same that it was previous, that, but the only thing is we will be taking extra space. That is, earlier we are using set, but this time we will be using DP. Okay, so vector of vector we will be taking. Initially I have I have made this 2D like vector. Okay, and the number of rows is equal to total rows, and the number of columns is equal to total columns, and initially they are containing -1. Okay, and basically we will return we will call this recur, and I have signed this DP. Okay, so what new thing I would be doing in this particular code is nothing, but I will check, I will keep the track of all the all the indexes that I have visited, right? And I will mark them with the result value, that at this, like if I am here, so I will mark this index in the DP, that is DP of 0 and 0 is equal to result. What is our result for now? The That is health. So what is our health for now? That is 1. Okay, then I will move here. So the health becomes 0 for DP of 1 comma 0. So I will mark it that DP of 1 comma 0's health was 0 at this particular index. Okay, and then I will basically return 0 because health has become 0. That means I have to return, okay, in this particular way. So see our okay, so let me just walk you through the code. The edge cases are the same. Okay, here as you can see, the only difference is from here. Okay, here I am checking the row is less than 0, it becomes greater than or equal to total rows. Okay, if the grade of row and column is equal to 1, that means we have to reduce the health by 1. If it becomes less than 0, then we have to return false. If the row and columns, that is, we are at m-1 and n-index, and we have to return health is greater than 0. That means if health is greater than 0, then it will return 1. Otherwise, it will return 0 only. Okay. And if none of these conditions satisfies, so suppose I am here. So dp of 0 comma 0 is greater than or equal to health. So health is initially -1. Okay. Oh, sorry. Health is initially what? 1. Okay. And dp of row and column is -1. -1 greater than or equal to health? No. So we won't return 0. and so that means we haven't visited DP of row and column yet. So I will mark it with health. Okay, so DP of 0, 0 will be containing 1. Okay, similarly again then I will move here. Okay, and then again I will be using the basically the same path. Okay, so the only thing is that here I'm using this DP, so as it is tracking the health. So basically, what does it says is if DP of row and column is greater than or equal to health. Okay, that means what? So that means that we have previously visited this particular uh, this particular grid of row and column. Okay, if we haven't, that means this value would be containing -1. Okay, because and it is a binary. This is a binary grid, so it will contain 0 or 1. So that this condition will definitely not satisfy. Like if we haven't visited this particular row and column index yet. Okay, so it will that means we have visited it. So if we have visited it and if its value is greater than or is equal to health, then we will return 0. That simply means, see, the value that's contain, suppose DP of row and column is 5. Okay, so we have visited this particular index earlier, and if I have visited this particular index earlier, and if I am revisiting it, that means by moving this particular index in previous time, we haven't find the answer. Okay, so suppose like in this particular thing, suppose health was 3. Okay, so suppose I have moved through this. Okay, the health has become from 3 to 2 here, then 3 to 1 here. Okay, then I have traversed through whole of there and I have moved like here. Okay, so at this particular point, the health has become 0. Okay, so it has returned 0. So basically, the thing is, if the health is containing 3 now, if I reach at this index again, like if I am following this particular path, okay, if I reach here again, that means, see, it will check that at this particular point when I reached previously, then what was the health? So the health was 1 and 2. 2 minus 3, that is 1 only. Okay, and now also I am visiting, okay, from this particular path. So again the health is 2 only, because here also 2 times 1 has come. Okay, so it was 1 only. Health was 1 previous time when I visited it, and health is 1 this time when I visited. So if it is equal, so earlier also I got 0. Okay, because when I visited this particular path, I didn't find the answer. So this time also I will definitely find 0 only. Okay, so simply I will return 0 from here. I won't move forward. Okay, so this is how it works. So uh, and suppose if I use this particular path, okay, so if I follow this particular index value, so at this particular point, health is 3. So at this particular point, health has become 2. Now suppose I move here, so health become 1. Then I move here, health become 0. Okay, so I didn't find the answer. So now suppose I follow this path. Suppose this. So health has become what? 3. It was 3, and now it has become 2. Okay, then suppose I follow this path. Again, I follow this, reached this particular index, and this particular index is having some value because we have earlier reached it. And what was the value it was having? It was having 2 value, because when we haven't visited that, that means it was -1, and when we visited it, that means it has become health -2. That is 3 minus 1 is equal to 2. Okay, and now our health is already 2, and as soon as I reach it, that means our health value, that is our health is 2, which is greater than and equal to 2 only. So 2 is greater than equal to 2. Yes, it is. So see, when I was at the similar condition, then also I didn't find the answer. So this time also I won't find the answer. Okay, that's why I will return 0. Okay, and why I have used this greater than is equal to sign? Because see, when my health was 3, okay, because suppose DP of row of column contains 3, when my health was 3, then also I wasn't able to find the answer following this path. Okay, now if my health is less than 3, suppose it's 2, then definitely I will not be able to find this particular path. Okay, because my health was 3, so that means I have encountered 3 ones, and then also I lost. So now my health is 2, and again I will encounter these those three ones. Okay, so definitely I will lose. Okay, that's why I will simply return 0. So now basically we have reduced our time complexity. So basically once we visited this particular index, so again I won't visit this particular path. So basically earlier I have visited this particular path. Now from here I won't visit this particular path again. Okay, I will simply return from here. So the complexity of this particular code will reduce from 4 to the power n into m to n into m only, because see we are traversing each like row and column value only one time. Okay, so hope you have understood this code. Okay, it is recursion only. Just we are using this dp vector, and we are storing the health in here, and we are basically tracking the health. Okay, at particular index value. So if I run it, yes, it is running fine. And if I submit it, yes, it is accepted. And see, the time complexity is also the minimum, like 29 milliseconds. Okay. So hope you understood this problem, guys. If you like this video, give me a thumbs up and subscribe to the channel. See you in the next video. Till then, goodbye.